have a process view and resource allocations. Okay, so this is really very important. You need to understand the states that are participating here in a process view. So this is the process view, states of a system. Okay, so there are say 1, 2, 3, 4, 5, 6, and 7, 6 states, right? So there are 6 states. How many states? We have 6 states. What are they? They are, say, first is submit, second is hold, third is ready,
Ready.
fourth is run, fifth is wait, and sixth is complete. Okay, submit, hold, ready, run, wait, and complete. This is actually the flow. Okay, so these are the 6 states. Okay, submit state means what? Here, this is the user. This is the user, and this user submits the task, right, to this particular submit state. Then from submit, this task is shifted to hold, right? Then from hold it come to ready, then run, and ready run. It actually moves in between ready and run. If there are certain requests, then it will go on to a wait, and if it is complete, the task is processed. Right? Task is successfully completed. Task is successfully completed here. Task is successfully completed here. Okay, so every state defines that task is completed, it is run and ready. So user submit its task to the submit state, then it comes to a hold. Okay, but if at all you need to work with these states, you need to think about resource. Okay, and these resources, first important resource is memory, second processor, third IO devices, right? And fourth important user has certain task, then user submits this. So probable question is like, okay, user submit the task, then where it is to be stored primarily, where it has to be stored. Yes, can you just tell me the answer, where it has to be stored or where it has to be kept? In the main memory. So the here for this submit, right, which resource you are in need of? Memory. Okay, if it is onto a memory, then once it is onto a memory, then it is shifted to hold. Again, in case of hold also, what you need a memory. Okay, okay, now the task is into a memory. Then question here to the hold is, how do we process? Yes, how do a system process it? What you need? What you need here?
Processor.
You need a processor. Okay, how do what is where it is to be stored? It is, your answer is say onto a memory. How do we process? By using processor.
Processor.
Right. So means what here? In case of ready and run, in this case, you need a processor. So processor here. You need a processor here, because processor is ready to execute the instruction. So at the hold also, you need to think of processor. At hold also you need to think of processor. Okay, at the ready run, okay, this is okay. Now but processor needs what? Processor needs something to execute. Processor need process to get executed, and and you are creating whatever the task that is being submitted by the user here has to be generated in terms of process at the hold. Okay, then there is ready and run. Okay, ready and run, these two state where the processor is going to work. Okay, now what if you need IO devices? What if the process needs IO? Okay, what if process needs IO? What you need if a process needs certain IO devices, then what you need? You need here devices, right? What you need? You need a devices here. So yeah, you need a devices. Devices. You need a devices. So means what? Whatever the process, say for example, just take a case here. If you have say a main, right? You define say integer x equals to 0, integer y equals to 0, integer z equals to 0. You are writing say print f some message. Right here you are writing scan f percentage d and a, sorry, and x, say for example this is x. Okay, so what here, say for example, as far as this instruction number 1, 2 and 3, they are considered like they are moved into ready and run. So it will say ready x equals to 0, again come back here, ready y equals to 0, again come back here, ready z equals to 0. Okay, printf, okay, it responded print. Okay, next scanf. So means what, here you need IO device. The scanf needs keyboard interface, right? This needs keyboard, so user needs keyboard device to add in data. And like once you made an IO request, you need to shift from a run to a wait, right? And from wait, again it will pick the data from a keyboard device, and again it will go to run. Okay, so means what, if your process needs an IO, then there is a IO device request, right? So means what, here it is say some say IO request. Okay, so you can change a state from here, from run to wait here. Then if this request IO completes, then again it shifted from wait to ready. Okay, and if this is done, then it runs to complete. Okay, so it means that these resources are to be required in each of the state. And I hope that you have got the submit. Submit state is a state where user submits the task. Hold is a state where user generates the process, means the process, whatever the user task is being submitted to that particular task, the process is being generated. This is important, that the process is being generated here, right? So at hold, the process is being generated and the process is being shifted, so that once the process is shifted, ready determines that the processor is ready to execute the process which is being supplied, right? And it is in between ready and run. So if you look at this particular mechanism, ready and run mechanism, this mechanism only, right? So this mechanism is referred as, in most general cases, this is called as mechanism. This is called as context switch. This is really very important. So processor is always busy into ready and run. So these are what, run, right, and ready. These are the most important states, and these two most important states are with respective to processing. right? And processor is executing process, right? So when process is in action, it is in between ready and run. Okay, so that this is ready and run. These two processes, these are process states. Process states where processor is in action. Processor, okay, is utilized. Okay, wait is a state where there is certain IO request. Okay, and complete is successful completion of the task. Now if you look the same into a broader view, you will find it here. Okay, so here is somewhere if you look at here, this is being submitted by task here. So if you look at this, okay, so here once it is being submitted, then you need to like say user, this particular fellow user has certain information associated, then it requires some device management to enter the data, right? Some event you need to generate, say for example you need to execute a process, right? So you certainly go for file, double click it and all that. So here you need to go for, so the important concept which comes here is called as SPOOL. Okay, this SPOOL stands for, can anybody tell me what does this spool stands for? This stands for, this spool stand for, yes, any idea? Any idea? This spool stands for simultaneous peripheral operation online. So SPOOL, right? So it is simultaneous peripheral operation online. Okay, peripheral I means device. It can be either input or it can be either output. So user submit the task, you need a information, you need a device management mechanism, it comes to hold. At hold, what is going to happen? The processor management is going to come, right? It generates a process, it assigns a memory, it creates a job, checks the device is available or not, check memory is available or not. If it is checking memory is available or not, what is going to come? The memory management is going to come. Check any devices are required or not. So it is device management comes, creates a processor. Processor management comes here, right? So it assigns a memory. So again, memory management comes. So if you look at ready, ready means what? Here the processor is ready to execute. So if you look at this, then it will check the processor management here. Check the status of processor. What exactly the processor is processor is available or not. If it is available, then the processor management traffic controller it checks. Okay. Accordingly, it checks the process management traffic controller also here also. Means like here process management is there. If the processor is available, then whether you are in queue, whether you are using queue or whether you are using whether you are being served in preemptive or non-preemptive mode, this this you have to decide. Preemptive, non-preemptive mode you have to decide. Okay, if you look at run to wait means what? Information management. You need a call, like for example you need a device management here. So means what? Ready, run to wait, you are the role is of device manager. Okay, you need process management. Okay, from wait, again process management comes into picture. And if you look at run to complete, whatever the devices that you are allocated, you are freeing that. Whatever the memory that you have allocated, you are freeing that. The processor which you have allocated, you are going to free that. Okay, and you announce here complete successful. Okay, but if you look at this, so you have a broad array of say you have a processor, you have memory, you have device, you have files. So what is this? These are actually resources, right? These are actual resources, and OS has to manage. Then OS, how OS is going to manage? First, important, OS keeps the track of resource. OS keeps the track of resources. Means whether the resources is available or not, available or unavailable. If it is available, if it is unavailable, if it is unavailable, then you need to go for some mechanism, right? In both the cases, available, in if it is unavailable. So it keeps the track of the resource. Second, it designs the policy to what? Allocate the resource. It designs the policy to allocate the resource. Then third, allocate the resource as per policy, and at the fourth point, deallocate, oblique, release the resource. Right. So OS has to think into this particular way. When OS is looking this all in this particular way, then OS is nothing but, this operating system is nothing but a resource manager. Then operating system becomes resource manager. So you just have to replace now, like how to deal with the processor, how to deal with the processor. Simple. Just instead of this resource, you just write down processor. Right. So means how OS looks at the processor, it keeps track of the processor. Processor is available or unavailable. If available, then you have to decide the policy to allocate that resource. If it is not available, then again you need to see the policy that when it can be made available, right? Okay. Then if it is available, then you need to decide the allocate the resource as per the policy. If it is not, if it is being allocated, it is being used, then you need to release, right? So that is deallocate or release the resource. If you look at the memory, then it keeps the track of the memory, whether it is available or unavailable. Available in the sense like if memory is of say if memory is say 100K, 100K memory is available, 100K is the size of the memory, and your task size is say task require 101K. So if it is available, then you need to decide the policy that when memory is say of only 10K, right? So it means that memory is available for that particular task. If it is available, then design the policy to allocate. Then as per the policy, allocate the memory. Once the task is complete, you need to free up the resource. Means this 10K memory needs to be free. Now look at the devices. Keeps the track of devices, is available or unavailable. Means it is connected or not connected. If it is connected, can it be allocated to a process? Yes or no. If it is not available, then can the queue is being maintained? Can buffer is being maintained? Can we supply a task? Okay, so if it is available, then design the policy to allocate the resource. Can buffer be is used? Yes, it is like that. So design the policy as per the policy and deallocate those once it is done. Okay, if you look at files, again, keep track of the file, whether file is available, exist on the through the disk or not. If it is onto a disk, whether it is being allocated for some or whether it is being held by some other process or not. Right? Track and status. Track and the state keeps the track and status of each and every resource. Okay, so design the policy to allocate the resource as per the policy and reallocate the resource. So if you look at this is how operating system is working as a resource manager. Okay, if you have any questions onto this particular topic, we will handle those questions. Otherwise, we have completed a task of completed a point system as a resource manager.